This tutorial shows you how to check for correlations among rasters and shows you what to do if you find correlations. This is necessary to perform ecological niche modeling. Including highly correlated environmental variables in the form of rasters in your data set would make the ecological niche modeling results more difficult to interpret and could potentially lead to model overfitting. This tutorial assumes you have RStudio installed. See the show notes below for another video that I made to install RStudio. This tutorial also assumes you have the R package enm tools installed. See the show notes below for another video I made on how to install it. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows or Mac computer for free. See the show notes for details. In fact, I am emulating Linux right now on my Mac computer using VirtualBox. I have a VirtualBox virtual machine pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling and GIS software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. Now let's go ahead and get started. The first thing you need to do is open up a web browser, which I have pinned to my favorites on the left or which you can find by searching below. Navigate to my website, joshbanta.com. Click on Tutorials. Type Control F to bring up a search window. Type in using enm tools, no spaces, in R. Make sure you type the whole thing. This is the one that we need. How to check for correlations among environmental layers and remove ones that are highly correlated using enm tools in R. Do not choose the one that says using standalone enm tools. Choose the one that says using enm tools in R. That's this tutorial. Click on it from the table of contents and it will take you to the right module. Then click on Files Needed for Tutorial. Click the download button. When the download is finished, you can close the web browser. Next, open up File Explorer, which I have pinned to my favorites on the left or which you can find by searching below. Navigate to your Downloads folder. The file we just downloaded is rastercorrelationschecknew.zip. Double-click on it. This opens up a program called Archive Manager, which is able to look inside of this zip archive directory. Inside this zip archive directory is the folder that we need. However, we cannot utilize this folder while it is still in the compressed zip archive. We have to uncompress this folder to another location. Find your File Explorer window if it is still open. Navigate to your desktop. Now come back to your Archive Manager. Click on the folder and now hold down on the click and drag the folder out of the Archive Manager onto the desktop folder that you have open in File Explorer. This has extracted the folder and all of its contents into your desktop. You may now close your Archive Manager software. And you may also close your File Explorer window. Next, open RStudio, which I have pinned to my favorites on the left or which you may find by searching below. click on File, Open File, navigate to your desktop, double-click on Raster Correlations Check New, and select Raster Correlations Check.r. Don't double-click on it, just have it highlighted and then click the Open button. Next, we need to set our working directory. Click on Session, and from the drop-down menu, select Set Working Directory, and from the drop-down menu, select Choose Directory. Navigate to your desktop and find the Raster Correlations Check New folder. Click on it once, and then click on Open. This is a quick splice to ask you to consider subscribing to my channel by hitting the subscribe button. It does not cost anything. It is totally free. But if you like what I am doing and want to support my work, I encourage you to visit patreon.com/joshbanta and make a voluntary contribution. The link is in the show notes below. Your support helps me to deliver new content and keep this channel current and vibrant. Thank you. We have now successfully set our working directory to the Raster Correlations Check New folder on our desktop. Next, highlight lines 3 and 4 and click Run. This calls the E&M Tools library and the raster library. I should explain, if you go to File Explorer and you navigate to the desktop and you look in that folder with the Raster Correlations Check New on the desktop, you will find several ASCII rasters, bio1 through bio9.asc. These ASCII rasters already have exactly the same spatial extents and resolutions. We will now highlight lines 6 through 15 to import these ASCII raster files into R. Highlight them and click on Run. Now we must stack all of those rasters that we've imported into R on top of one another into one stack raster object. To do that, highlight line 17 and click on Run. Now we will test for correlations among the different rasters. Highlight line 19 and click on Run. This will take a few minutes. You'll know that it's finished when you see the blue greater than sign appear here at the bottom. I'm going to time-lapse this. Next, we need to write these calculations of correlations to a file. Highlight line 21 and click on Run. In reality, if you were working with your own data, you would put in the names of your rasters here that you wanted to import, and you would give a name to the R object for each of the rasters that you imported of your own data. And you would stack here those R objects of your raster data. Since R has finished running and we have written the results to a file, we can close RStudio. Make sure that this save icon is grayed out, meaning that we have already saved our R script. Then go to File, Quit Session. It is okay to click on Don't Save. Don't Save is referring to the console, not to the R script. Now let's look at our results. Double-click on the raster correlations folder on our desktop. Scroll down until you find correlations.csv and double-click on it. This will open up a program called Libreoffice, which is the open source equivalent of Microsoft Excel. When you have the text import dialog window open up, simply click OK. I'm going to get rid of Show Tips on Startup, and I'm going to click OK. I'm going to get rid of those release notes. The next thing to do is to come up to the corner here and go to File, Save As. And we're going to save this as the Microsoft Excel 2007-365 format that ends in .xlsx. And now we'll click on Save. Uncheck the box and check Use Excel 2007-365 format. Next, we need to freeze the panes so that we can look at other places on our screen. Put the cursor in position B2. Then select View, and from the drop-down menu, select Freeze Rows and Columns. Let's go ahead and save our work again. Go to File, Save. So now let's talk about what we're looking at. Bio 1 through Bio 10 are different environmental layers. They're climate layers. One refers to temperature, one refers to precipitation. And these numbers represent the correlations between two environmental layers. A correlation of 1 means that two environmental layers were perfectly correlated. So Bio 1 and Bio 1 are perfectly correlated because they are the same thing. That means that in every pixel of the Bio 1 raster layer, the pixel in the Bio 1 raster layer in the same position has the exact same data. Of course they do because they're the same. But let's compare Bio 1 to Bio 2. Here we see a correlation of -0.66. This means that the data contained in Bio 1 tends to be similar to the data in Bio 2, where a high number in Bio 1 corresponds to a low number in Bio 2, so they tend to be the mirror images of one another. But in that way, they are still highly inversely correlated from one another. Mirror images of each other are still considered to be highly correlated with each other. We call that highly inversely correlated. And I say that they're the mirror images of each other because there's this negative sign here. Now, comparing Bio 1 to Bio 10, this number is 0.89. These correlations range from -1 all the way to +1. A correlation of +1 would be a perfect correlation between two rasters. A correlation of -1 would be a complete mirror image correlation of two rasters with each other, where whenever the number is very high in one position in one raster, the number will be very low in the same position in the other raster. That would be if it was -1. So a number of 0.81 means a high correlation between Bio 1 and Bio 10. What we need to do is to remove from our data set all of the environmental layers that are correlated with something else with a correlation that is greater than 0.7. That means a correlation greater than +0.7 or a correlation greater than negative 0.7. So let's start by looking at the first column for Bio 1. We're going to find all of the correlations that are greater than 0.7 or greater than negative 0.7. The first one we have is Bio 4. Bio 4 is highly negatively correlated with Bio 1. 0.78 is negative 0.78 is greater than negative 0.7. It's more negative than 0.7. It's closer towards negative 1. So this is a very high inverse correlation. Because it's a larger negative number than negative 0.7, we need to remove one of these two environmental layers. We either need to remove Bio 4 or Bio 1. The choice of which one to remove is arbitrary. With your real data, you could keep an environmental layer that is easier to understand. For our purposes, we will eliminate Bio 4. Click on the row 5, which corresponds to Bio 4. With the entire row highlighted, select Format. From the drop-down menu, select Text. From the drop-down menu, select Strike Through. This reminds us that we have removed Bio 4 from our data set. Now we need to do the same thing to Bio 4 in columns. The important thing to know here is that you are looking at what's called a symmetrical matrix. The comparison of Bio 1 to Bio 2 shows the correlation between those two environmental layers. But if we were to go and look here between Bio 2 and Bio 1, this also shows the correlation between those same two environmental layers. So the lower diagonals contains the same information here as the upper diagonals. And we're talking about the numbers above and below these ones that go through the middle of the symmetrical matrix. So we need to also cross out Bio 4 not just from the row, but we need to cross it out from the column as well. So highlight the E because that corresponds to the entire column that contains Bio 4. With that highlighted, go to Format, Text, Strike Through. And now it is crossed out, and we know not to pay any more attention to the layer Bio 4. Let's go to File, Save, so we don't lose our work. Let's look for other correlations that are also very high. 0.96 is greater than positive 0.7. So this is also a very high correlation. Bio 1 and Bio 6 are highly correlated. Therefore, I choose to eliminate Bio 6. We could have eliminated Bio 1 if we preferred. Click the number 7, which corresponds to the row for Bio 6. With the entire row highlighted, go to Format, Text, Strike Through. Now find the Bio 6 column, which contains the same information. Click on the G, which highlights the entire column. Go to Format, Text, Strike Through. Next, I see that Bio 7 is also very high. So we will highlight the row. And then when I say high, I mean that it is negative 0.83, which is a very high inverse correlation. It's higher than our cutoff of negative 0.7. Remember, our cutoffs are negative 0.7 and positive 0.7. Correlations or inverse correlations more extreme than either of those cutoffs are too high, and we need to remove one of the environmental layers. With Bio 7 highlighted, go to Format, Text, Strike Through. Then find the column for Bio 7, click on the H to highlight the whole column, and do Format, Text, Strike Through again. And then we'll save our work so we don't lose it. We still have one more correlation that's very high, and that's between Bio 1 and Bio 10. I choose to remove Bio 10. Highlight row 11 and do Strike Through. Then find the column with Bio 11 find the column with bio 10 rather, and do a strike through. So now we've gone through this column here for bio 1, and we've eliminated any environmental variables with a correlation greater than 0.7 or an inverse correlation that is more extreme than negative 0.7. Now we will do the same for the column bio 2. I am not going to show you that here, but I want you to do those same steps that I did for the column bio 1. I want you to perform them for the column bio 2, and I want you to show that in your video recording. Then I want you to do that for bio 3. Now you can skip any columns where the entire column is crossed out. But if there's anything within a column that's not crossed out, you have to check the column. Go through and do all of the columns that are not yet crossed out, all the way through bio, and you don't need to do bio 10 because it's already crossed out. And as you're going along, you're going to cross out more columns that you won't have to do. But go through and check in any column that isn't yet crossed out as you're going along. And make sure to save your work. When you're finished, the environmental variables that are not crossed out, whichever ones those will be, are the environmental variables that you would then include in your ecological niche modeling using the program Maxent. You would only use the columns that survived being crossed out.